Hi, food waste friends. So let's talk about this Ed puzzle. You're doing something really similar to what everybody is doing in class, just on your own time. So what are you going to need for this? A calculator. Your phone is fine. You're just going to be doing some multiplication and division. And then you need a pencil, something to write on, just so you can kind of track your notes and things, because you're going to have to type in your answers and you might need to carry some answers forward. And then attached to this assignment in Google Classroom are some sheets just to help you outline your thinking and to give you some better descriptions while you work and think and the video is paused. So I'll give you a second to get all that together. Great. So reminders and updates, you should be filling out your food waste log, so make sure you are on that. You need to do 2 days of it. So if you haven't started, you could start now. Get going. Okay, so today we are going to look at the life cycle of a cupcake. And we are going to do this by watching a video that doesn't want to show up because YouTube is having issues. So it's not right here. I'm going to post the link right here. I want you to go watch it. It's about 3 minutes. It's interesting. It's exciting. So go watch that and come back and you'll answer a question about that video. Great. So the question here now is, how can we figure out how to improve the life cycle of a product? So what that video was really talking about was, how can we make life cycles be as circular as possible? So how can this vest become a new vest? I know Patagonia has done a lot of work with this, where they have their worn wear program, or they're actually taking fleeces and turning them into blankets and like chopping them up so that they look really cool, and people are continuing to use these things. So how do we assess these? And this is something that engineers are doing a lot of. They're doing something called a life cycle assessment. So you think about where the inventory is coming from, you're thinking about how that impacts the environment, and then you're thinking about what you can do to improve it. So inventory is when we're calculating data, we're thinking, it's called cradle to grave, or what we like to say is cradle to cradle is the circular idea. So cradle, when you think about something being born, when you're making a product like this vest, can you get it to go back into a new cradle when I'm done wearing it and it isn't cool anymore, although I think it will always be cool. How can you get it to be a new thing? There is also discussion about cradle to grave. So where does it go at the end? Usually the grave is like the landfill or perhaps a compost. What's the end of its life cycle? So when you look at impact analysis, which is what we're really going to start thinking about today, is you're thinking about environmental impact. So that comes down to mainly how much energy it takes to produce things, and then how much greenhouse gases are being emitted at the end, and then compare some options to minimize those. So then at the end, we can make recommendations and say, hey, this is what we should do, and this is what that product does. So should it only be used, like if a product has really intense greenhouse gas emissions, but perhaps it's a vaccine, maybe that's worth it, and we can kind of do some optimization calculations there. Okay, so what we are going to be studying are cupcakes, because why not? And we're going to be looking at 6 different steps in the life cycle and where all of those things come from. So we have all the dry ingredients, all the wet ingredients, putting them together in their liners, baking them, making frosting, and then finally the actual cupcake. So we're going to be thinking about harvesting, processing, think about transportation, right? So if sugar, where does sugar come from? Well, it has to grow in way warmer places, unless we're talking maple syrup or honey, a lot of sugar cane or beet sugar. So those have to be transported to us. That emits greenhouse gas. Same with wet ingredients. Where are your eggs coming from? Are they being shipped from far away? Or I actually have chickens and all of my eggs come from about 20 feet from my house, which is pretty cool. So all those things coming in, transporting them. Then we got to mix them and make them. We actually need to make liners too. And what kind of liners are we going to use? Are we using paper ones? Are we using aluminum ones? What are we doing with the liners at the end? Are they going to the landfill? Are they going to the compost? How much electricity are we using to actually bake them? What's going on with all the frosting? How are we disposing of this? Okay, so in class, groups are going to be doing different ones. You at home, you are just going to be looking at the last step, the disposal in the landfill versus the compost. You'll actually also get to look at what we can do with aluminum going into the landfill or being recycled, which is pretty cool. So what we're doing is we're going to be able to calculate for each of the steps of making a cupcake, how much energy it takes, and then how much greenhouse gas it emits. And we're just doing CO2 to kind of keep things simple. So you are going to be doing disposal at the end. So let's just look at an example. Just so you can see how the rest of those are being calculated. So one example would be for the frosting, which is actually one of the most energy intensive because of all that sugar. So we have sugar and the milk too. Oh, butter. Butter takes a lot of energy. So we need all this energy to produce, and you can see some calculations are going to need to be done. The recipe card is for 12 cupcakes, and some of these energy and greenhouse gas amounts are for smaller amounts than we need here. So some multiplication we need to happen. So groups are going to come through and calculate how much it takes energy-wise and greenhouse gas-wise to make 12 amounts of frosting for 12 cupcakes. What you are going to be doing is looking at disposal, and we have multiple paths. So this is the time where you're going to want to make sure to pull up this disposal page, and I'm going to be asking you a series of questions, okay? And we'll put those into the Ed puzzle, but you'll want to write them out. So have a piece of paper, have this pulled up so you can write it out. So let's just start with the paper liner, and let's think about what happens when they go into the landfill. So go ahead, this is for 1 cupcake. Go ahead and calculate the energy for 1 cupcake, and then, or for 12 cupcakes, and then the greenhouse gas emissions for 12 cupcakes. Great, nice job. Now let's look at composting a paper cupcake liner. Something that's cool is it's actually negative CO2 emissions. It traps carbon, which is pretty cool. So go ahead and calculate energy for 12 cupcakes and then greenhouse gas emissions for 12 cupcakes. Okay, so here we are. We're going to be able to look at aluminum, and I know I just read on the sheet. It was a tough day. But you are going to calculate the energy for the aluminum liner, greenhouse gas emissions for the aluminum liner. Okay, so go ahead and get those done. Okay, now let's think about recycling instead of sending them to the landfill. So look at energy and CO2 for that. And make sure that you have those all written down somewhere so we can use them. Okay, so you can compare your answers. So here are the answers for everything, the energy usage and the greenhouse gas emissions for everything. So disposal isn't really the biggest part of our greenhouse gas emissions. It's a lot of that transportation, right? And then energy use, how much energy is it taking to do all of these things? And look at that frosting. That's huge. Okay, so here's your job right now. This is the life cycle assessment in terms of energy and greenhouse gas emissions for 12 cupcakes. So what you need to do next is have your piece of paper out, get this answer down. Tell me how much energy it takes total to make 12 cupcakes. Awesome job. All right, let's now calculate how much greenhouse gas emissions are caused by making these 12 cupcakes. Okay, nice. So to end this, what I want you to do is now tell me how much energy does it take for 1 cupcake. If you just told me for 12, tell me how much it would take for 1. Now calculate what the greenhouse gas emissions are for 1 cupcake based off of this. Okay, so finally, and I'd like a slightly longer answer to this. So now that we've looked at the life cycle assessment, it's time for the improvement analysis. So what could you change in the cupcake life cycle to improve its impact on the environment? So don't just say it can go to the compost. Think about a couple more interesting and thoughtful ideas for ways along the life cycle that you could reduce some of the energy or greenhouse gas emissions. Nice job, food waste pros.